Okay, Bismillahirrahmanirrahim. Assalamualaikum. So today we are going to continue with chapter 4, basic map principle in agriculture. Okay, so what is a map? Okay, by definition, a map is a diagrammatic representation of an area of a land or sea, showing physical features, for example, cities, road, buildings, trees. Okay, uh, but in agriculture, um, a map can show more than that. Okay, uh, a map can show the physical location of the object, but it is most valuable when it shows the spatial relationship between the objects. For example, if you have a yield map, okay, why there are certain area in the map is having high yield, okay, what caused to that, okay, then we can find the relationship between the high yield and other uh, attributes. Okay, for example, is it because of the soil fertility, is it because of they having a good irrigation management, okay, having a good pest and disease practices. Okay, so in agriculture, uh, a map can show the different level. This is the example used maps for agriculture. Okay, show the different level of soil nutrients, the areas of high and low yield, and differences in topography. So the ability to create maps that display this spatial variability is fundamental to precision agriculture. Okay, uh, so there is another way of thinking about map, okay, which is a map is a model of an area, which is a small representation of an object or area that is meant to duplicate the object or area as closely as possible. Okay, so prior to computer and GIS, many farmers had an aerial photo of their farm, okay, and had a hand-drawn maps of each of their field. Most of the time, the number of the acres and the next year's crop would be written within the boundaries. Okay, these maps were simple and just record a basic information. Okay, they were not to scale and didn't have perfectly accurate boundaries. Okay, uh, they are just used for documenting basic information about the field with little analysis. Okay, but knowing that the GIS can give value to the data, okay, uh, they already change, okay, from the hand-drawn to computer and GIS map, okay, which is they like the idea of knowing yield characteristic in specific areas of the field and being able to see the patterns of nutrients compared to the yield. It is more detailed map. All right, so that is just for a brief for introduction. Okay, so in this topic we are going to learn about the coordinate system. Okay, we are going to learn about two types of coordinate system, which is GCS and UTM, and then we also have projection, datum, scale, and types of thematic maps. Alright, so let's go to coordinate system. Okay, as I mentioned earlier, we there have a lot of coordinate system, but the most common use for GIS is a GCS, Geographic Coordinate System, and also UTM, okay, Universal Transverse Mercator. Alright, so coordinate systems, okay, used for systematically identifying the location of an object on a map, usually with a grid. Alright, so the simplest coordinate system is a duplicate in computer spreadsheet where columns with columns and rows. Okay. Each coordinate system is defined by this following factors. Okay, number one, its measurement framework, which is either geographic or planimetric. Unit of the measurement, okay, and then the definition of the map projection for projected coordinate system, and other measurement system properties, okay, such as spheroid of the reference, the datum or central meridian, and possible shift in x and y directions. So here are the two common types of coordinate system used in GIS: global or spherical coordinate system, okay, and then the other one is the projected coordinate system, such as UTM, okay, Universal Transverse Mercator. Alright, GCS, okay, the coordinate system used in geography that most people are familiar with is this system, okay, which is a grid figuratively created on the surface of the earth using lines of latitude and longitude. Okay, so you can refer to the diagram, okay, uh, the latitude and the longitude. Okay, so the latitude is the lines used to measure how far north or south an object or feature is from the equator. Okay, equator is the reference line for the latitude, okay, starting at 0. Okay, the range for latitude is from 0, which is the equator, and then going upwards to the north pole is positive 90, and then going downward to the south pole is negative 90. So all latitudes north of the equator are denoted with and or positive value, while all latitudes to the south of the equator are denoted with S or a negative value. Okay, while for the for longitude, it is the columns of the GCS. Okay, the lines run north south from the north pole to the south pole, and then used to measure how far east or west an object is from the prime meridian. So prime meridian is the reference for longitude. Okay, so these lines is not parallel, okay, being wider at the equator and then becoming narrower as they approach the poles. Okay, so the range of from 0 at the prime meridian, which is runs through Greenwich in England, okay, to uh, plus 180 degree to the east and negative 180 degree to the west. Okay, using latitude and longitude together divides the earth into 4 quadrants, okay, which is the northern hemisphere is divided into east and west quadrants, and the southern hemisphere is also divided into east and west quadrants. Okay, alright, so it should be noted that the latitude and longitude are expressed as degree, decimal degree, DD, or degree minutes, DM, and degree minute second, DMS.